Hello, this is Dr. Schleif with another worked example. Here we've got a wave traveling along a coiled spring. The graph shows the variation with time of the displacement of a point on the spring. And we want to know what the frequency of the wave is. Follow me as we go for an adventure along the wavefront. One wave and 1.5 waves.
Good morning, students. This is Mr. Fry, hopefully with the last testing announcement. If you have a moment, teachers, please review that list and send students who are on the makeup test list to 13105 at this time. Once again, teachers, please review that list that I sent out this morning and send students to 13105 at this time.
1.5 waves, not wavelengths, right? Because we're looking at time, but there is 1.5 waves per 0.2 seconds. Waves per second is the frequency, right? Waves per second. Hertz are reciprocal seconds. And so we get waves per second or oscillations per second. So 1.5 divided by 0.2. Stand by. 1.5 over 0.2 is 7.5, which is choice D. The question was, why not one wave? It's difficult to read off this graph exactly what that value is. Okay, but I could calculate it now. In other words, what's the period of this wave? It's like somewhere between 0.1 and 0.2, like 0.1 something. You could kind of use your judgment, maybe 0.125, I don't know. But it neatly intersects the x-axis right here at 0.2 seconds. And I can see like that's an exact 1.5 waves, right? So there's another half of a waveform. You could have said, we could have followed this sort of roller coaster ride here and said 1 wave, 1.5, 2 waves, 2.5, and so 3 waves per 0.4 seconds. And you see that's the same ratio here, right? 3 waves per 0.4 seconds. So if we had 7.5 and we took the inverse of that, 0.13 repeating. So that's the actual time period, right? Because it's the inverse of this frequency. And so this is 1/3 of the way, right? So it's 0.13 repeating. And so because it's impossible to sort of just read that off, you have to find a place on the x-axis that more neatly intersects. And so either 3 waves is 0.4 or 1.5 waves is 0.2. Those are the places on the x-axis that, or you could kind of maybe see like this much of the wave is right there at 0.3. So how much of the wave would that be? 1, 2.25, right? So you have 2.25 waves is 0.3, and that preserves this ratio also. Lots of ways to think about physics. Keep thinking on it though. See you next time.